वेलकम स्टूडेंट्स, आपका YouTube चैनल शंकर कोचिंग में स्वागत है। मैं प्रोफेसर प्रेम शंकर आज 10th क्लास के स्टूडेंट को चैप्टर नंबर 3 NCERT बुक से मैथ्स पढ़ाऊंगा। आप इस वीडियो को अंत तक देखें। अगर आपको ये मेरा वीडियो अच्छा लगता है तो आप इसे लाइक करें, सब्सक्राइब करें और अपने दोस्तों के साथ शेयर करें। तो चलिए वीडियो स्टार्ट करते हैं। See, the chapter is pair of linear equation in two variables. So I will discuss the introduction first. So in the part of this introduction, we have the two variable that is your x and y. This is the two variable. So if I take this two variable, so I will take the help of what linear equation written there. So the power will be what? So the power will be 1 will be there. So if I take the linear equation of the two variable, then obviously it will be your ax plus by plus c is equal to 0. This is your linear equation in two variable. So since variable is 2, so in that case I need two equations. So one is your, suppose I am writing here a1x plus b1y plus this c1 is equal to 0, and another equation is a2x plus b2y plus c2 is equal to 0. So whenever we take any this incident or any question, so in that case two variable will be there. So this is the introduction part. We'll see the methods for solving this linear pair of equation. So as I already told you that two variable is there. Since two variable is there, that indicate that two linear equation must be there. Okay, so for methods of solving the linear pair of equation, each there are basically two methods is there. First one is the graphical method. And second is your algebraic method. This is the algebraic method. Algebraic method. So one is the graphical method, another is the algebraic method. And if you see in the algebraic method, there is again these three methods are there in the algebraic method. The first one is your substitution method. Substitution method. And the second one is your this substitution method, and second is your elimination method. Elimination method. And the third one is your this is cross multiplication method. I have the cross multiplication. Cross multiplication method. So I will discuss one by one. First of all is the graphical method. In this graphical method, this name suggests that you have to draw the graph. Okay, so graph for the graphical method, draw the graph. So I will discuss this graphical method first. In the graphical method, what we will do, I will take one graph paper. I will take for the graphical method. I will take one graph paper. On the graph paper, I will plot the both linear equation. Both linear equation means I have what? I have the a1x plus b1y plus c1 is equal to 0, and a2x plus b2y plus c2 is equal to 0. So this is the general equation of this linear pair of equation, and I will plot the graph of these two equations. I will plot the graph of this one. So how to plot this one? One very simple way is you just write the both equation in terms of y. In terms of y, I mean to say this first equation will be how much? This is your b1y. This is equal to minus c1, and this is minus c1 minus a1x. So y is equal to, this is minus c1 minus a1x, this divided by b1. I will just change the subscript. So in the second case, in the second linear equation, this is y is equal to minus c2 minus a2x divided by b1. I will writing here b2. I'm just change the subscript here. So after writing in this form, I will plot the graph. I will plot the graph of this one, and let's suppose this is what, this is the x-axis and this is y-axis. So for plotting the graph, I need only 2 points, because after the joining that one, we'll get the equation of a straight line. So I will put the values here. Now see, there are many cases, mainly three cases there. Number first is that both line will intersect. Okay, the line will intersect. Okay, so suppose I'm taking in this way. Suppose the line is intersecting like this. It is intersecting like this. Okay, and this is the first case, intersecting. So this will be the first case. Or what will happen? Or this is for the intersecting line. Or the line is what? Or the line is parallel like this. Suppose the line is like this, parallel. This is the case of the parallel. Or coincident. Or the points are in this way, here coincident. This point are coincidents. Okay. So the one is what? One is your intersecting, another is your parallel, and third one is your coincident. These are the cases here. This is what? This is, let's suppose, first case. This is first case. This one is your parallel line, second case, and this one is your coincident. So this is the third case. Okay. Now for the first case first is what? The case first is what? Intersecting. Okay, intersecting. So for the case of the intersecting, it is cutting at one point. So if it is intersecting, so that means what? A1 by A2 is not equal to B1 by B2. A1 by A2 is not equal to B1 by B2. It is intersecting. Okay. So how many solutions will be there? One solution. Okay. And that is nothing but that is your unique solution. This is your unique solution. One solution, or you can say unique solution. Okay. Now case 2. Come to the case 2. Case 2 is what? Case 2 is the I'm taking case 2. Case 2 is the this is parallel lines. Okay. So case 2 is the parallel lines. So for the parallel lines, what is happening in that case? For the parallel lines, you have, this is A1 by A2. This is equal to B1 by B2, and this is not equal to C1 by C2. So this is the case of parallel lines, and in the parallel lines you have the no solution will be there. Okay, for the parallel line. Come to the case third. Case third is what? Case third is in this case coincident line. So case third is this is coincident. Yeah, coincident. And the coincident, what is the, this is condition, that is your A1 by A2 is equal to B1 by B2 is equal to C1 by C2. Now, if the ratio is like this, so this will be a coincident line. This is coincident line. These are the points. Okay. So for the coincident line, how many solutions will be there? This is your infinitely many solution. Infinitely many solution will be there. Many solution. Okay. So this is all about your algebraic method, and for drawing the graph, you have to write the equation in terms of y, and after plotting the graph, these are cases will be there, and then seeing that graph, can divide that nature of graph into three possible ways. That is your intersecting, parallel, and coincident. Okay. So this now in the algebraic method, there are again three methods are there. One is the substitution method, another one is the elimination method, and lastly the cross multiplication method. So first of all, I will discuss this substitution method. Substitution method I will discuss. So come to the case of the substitution method. This is your this method is a, here it is the substitution method. So for in the substitution method, again the general equation for the linear equation of two variable is, again it is a1x plus b1y plus c1 is equal to 0. And another equation is your a2x plus b2y plus c2, this is equal to 0. So two equations are given. So in the substitution method, what we are doing, in the substitution case, I will take this value of x I will take, and then that value of x I will put it here. So suppose this is the equation 1, this is equation 2. So from equation 1, so this is how much? So this is your a1x, this is plus b1y plus c1 is equal to 0. Okay. So I will find the value of x. So value of x will be how much? So this is your a1x is equal to minus, here it is your b1y plus c1, and this x is equal to minus b1y plus c1, this divided by a1. So this is what, this is the value of x. So this value of x, the value of x I am getting here. So this is, I put it here in this equation 2. So this is the substitution method. Since we are substituting the value of x in the equation 2, so that means what? That is the substitution method. Now come to the next one, that is the elimination method. Elimination method. So we will see in the case of the elimination method. Elimination method. So in the elimination method, again I will write what? I will write the both of the equation. This is a1x plus b1y plus c1 is equal to 0. and I have then a2x plus b2y plus c2, this is equal to 0. In this I want to use this elimination method. Equation 1, this is 2. So elimination method, I have to eliminate the either the coefficient of a1 or the coefficient of this y, either the coefficient of x or the coefficient of y. If I eliminate that one, so I will get the value of this x and y. So let's suppose I want to eliminate the this coefficient of x. So in that case, what I will do, so this is a1x plus b1y plus c1 is equal to 0. Here it is a2x plus b2y plus c2, this is equal to 0. So this is your equation 1, this is equation 2. I want to eliminate the coefficient of x. So I will multiply this a1, this I multiply by what? a2, and this I multiply by a2 and then by a1. So I will get what? I will get, in this case, I will get here, after multiplying, I will get here a1 a2x plus b1 a2 plus c1 a2 is equal to 0. And if I multiply by a1, so I will get what? I will get a1 a2x plus a1 b2 y, a1 b2y, a1 b2y plus a1 c2 is equal to 0. Now you can see here this coefficient is, this is the equal coefficient. So if I subtract this one, so obviously what will happen? This will be cancelled out. So if I subtract this one, so after subtracting, this will be the cancel out, and what I will get? I will get here b1 a2 minus a1 b2. This is y, and then plus this is your c1 a2 minus a1 c2 is equal to 0. So I will get the value of y here. After getting the value of y, I will put in the equation, any equation, and then I will get the value of x. So this is the elimination method. Now we will start the last method, that is the cross multiplication method. This is the part of the algebraic method, and this is a cross multiplication method. In this method, again the same case, the general form of the linear equation. So that is your a1x plus b1y plus c1 is equal to 0. And the another equation is your a2x plus b2y plus c2 is equal to 0. So two linear equations are there, and two unknowns are also there. So I want to use another method, that is the cross multiplication method. Let's suppose this equation is 1 and this equation is 2. So I can, if I multiply this equation by b2 and this equation by b1, if we multiply in this way, so what I will get what? Here it is a1 b2x plus b1 b2y plus b2 c1 is equal to 0. And likewise here also, what is the value here? Here it will be your this is your b1 a2 b1 a2 x plus b1 b2 y plus b1 b2 y plus how much this will be? This will be a b1 c2. Okay, so this is equal to again 0. I'll multiply this by b2 and this by b1. So what will the values there? So if I subtract this one, I will get what? I will get this. This will be cancel out. So I will get here. This is a1 b2 minus b1 a2 x. This is here, it will be plus this is your b2 c1 minus b1 c2. This is equal to 0. So what is the value of x then? So the value of x is then equal to, this is equal to, x is equal to how much? This will be your how much? b1 c2 minus c1 b2 is divided by a1 b2 minus b1 a2. This is the value of x. What we had done, we had just taken the eliminate the coefficient of y. Okay. Now similarly we can find the value of y also. Y also we can find it here. So let's suppose this how to find the y. So see, the name implies here cross multiplication. So if I write it here, a1x plus b1y, c1 is equal to 0. This is your a2x plus b2y plus c2 is equal to 0. Okay. Now we are applying this method. Which method? That is the cross multiplication method. So I will write it in this way: x is equal to then your y is equal to then 1 upon. As the name implies, cross multiplication method. So I will use the cross multiplication here. So how to write it? So this x will be here x upon. So mind it, this is your what? b1 c2. So this is b1 c2 minus b2 c1 b1 c2 minus b2 c1. Then y upon. So y upon means what? This y will be in this way. So cross multiplication will be how much? This will be your c1 a2 minus c2 a1 minus c2 a1. Now I will take this one constant. So 1. So cross multiply will be a1 b2 minus a2 b1. a1 b2 minus b1 a1 b2 minus b1 a2. So immediately you will find what x is equal to. This is b1 c2 minus b2 c1. This divided by a1 b2 minus a2 b1, and y is equal to how much? This is your c1 a2 minus c2 a1. This divided by how much? a1 b2 minus a2 b. So this is the value of x and y. Now in this case, let's suppose this portion is going to be equal to 0. So how much will be here? So this is your a1 again three conditions are there. One is your A1 by this A1 by A2 is not equal to B1 by B2. A1 by A2 is not equal to B1 by B2. So in this case, unique solution will be there. One solution. Unique solution will be there. Unique solution. And A1 by A2 is equal to B1 by B2 is equal to C1 by C2. So in this case, how many solutions will be there? So this is constant, so infinite many solutions will be there. Infinite many solutions will be there. And lastly, when A1 by A2 this is equal to B1 by B2 is not equal to C1 by C2. So in this case, how many solutions will be there? It has no solution will be there. It has no solution. No solution. Why? Suppose you are putting the value here, A1 by A2 is equal to B1 by B2. So in this case, this portion will be going to be 0. So that means no solution will be there. So it is the cross multiplication method. Now we see the equation of reducible. In many cases, the equation which is given is not in the linear pair. If in the denominator there is present x and y, in that case we will reduce that equation into linear pair of equation. So when to reduce the equation? So when in the denominator the x and y is present, so in that case I have to reduce that equation to get the solution. Okay. So let's suppose I am writing here a by x is a by x and plus this is b by y is equal to 3. So you can see clearly here x is where? It is accent, it is in the denominator. Y is where? Y is also in the denominator. That means I have to reduce this equation into linear pair. So what I will do? I will do the 1 by x. I will assume this as a x and 1 by y. This as a capital Y. So I will, if I write it, I will get the ax plus b capital Y is equal to 3. So this is one case. Okay. Now let's suppose another one. Let's suppose a by root x plus b by root y is equal to 3, or let's suppose 2. So in this case also x and y are in the denominator. So how to reduce it? So for reducing 1 by root x, I will assume this is x and then 1 by root y or root y, this is equal to y. I will put the value here. So it is your ax plus by, ax plus by, this is equal to 2. Okay. Now, so the basic thing is when in the denominator this x and y is present, in that case we have to reduce that equation. One more I am taking. Let's suppose it is a by 3x plus y plus b divided by 3x minus y is equal to, let's suppose some constant or some constant c. Again you can see here clearly that the x and y are in the where? It is in the denominator. So I will write it here, 3x plus y capital X and 3x minus y is equal to capital Y. So it is your ax plus b capital Y is equal to 6. And lastly one more I am taking. Let's suppose one equation is given like this, very important one, ax plus by is equal to, let's suppose c into x plus by is equal to c into xy. Suppose it is like this, and so in this case also, see, obviously x and y is in the not in the denominator, but if you shift it here, so you will get what, ax divided by xy plus by divided by xy. So this is equal to c. So see how I'm getting ay plus this bx is equal to c. So see here, y and x, it is again in the denominator. So I will reduce this equation. So suppose I assume here 1y is equal to y and 1 by x is equal to capital X. So simply I will write ay plus bx is equal to c. So in this case also, so whenever x and y is in the denominator, if it is in the denominator, then I have to reduce the equation into linear equation. Thanks for watching. If you have any doubt, write in the comment box. If you like the content of video, please like it, subscribe it, and share with your friends. Thanks.